In this video, we're going to go over section 10.A, which is called Exponential Functions and Logarithmic Functions, or that's what I named it. This section is really just a review of exponential functions and logarithmic functions, and you may not have seen this before. That's okay. This entire homework is just practicing using the exponents and the logarithm buttons on your calculator. So I'm going to go through and I'm going to tell you about exponential functions and logarithmic functions, and then we're going to do some practice on the calculator. I'm going to talk about exponential functions first. A function in which x appears only in the exponent is called an exponential function. Okay, so this is where your unknown variable appears in the exponent. So here we have an example. It says, for example, y equals 2 to the x is an exponential function. That's because the x, which is our independent variable, x is in the exponent. And it says note y is the dependent variable, x is the independent variable. That means that y depends on x. So the value of y depends on what the value of x is. This is the formal definition of an exponential function. It says, you don't have to have this memorized, but you should be able to recognize whenever you see this, a function in this form, you should be able to recognize that that is an exponential function. Okay, so it says an equation of the form y equals b to the x, where b is a positive constant, but b cannot be 1, is called an exponential function. The positive constant b is called the base. All right, so an exponential function has the form y equals b to the x, where b is some positive constant, but b is not allowed to be 1. All right, so some examples you could have, just like we saw a minute ago, y equals 2 to the x, that's fine. You could have even something like y equals 1.2 to the x, or y equals 0.9 to the x. It just has to be a positive number, b does. And it says b is not allowed to be 1. And the reason that is imagine if b was 1. So we would have y equals 1 to the x. Any number that you plugged in for x would still give you back 1. Right? So 1 raised to the second power, 1 squared, is still 1. 1 cubed, which is 1 raised to the third power, that's still 1. 1 raised to the 100th power is still 1. And that's not an exponential function. One of the main characteristics of exponential functions that sets them apart from other functions is the fact that they either grow really fast or they decrease really fast. And so if we had 1 in there like we just talked about, any power that you raise that to is still going to be 1, and therefore it wouldn't be growing really fast or decreasing really fast. Right, so again, it's not allowed to be y equals 1 to the x, because any number that you plugged in for x would still give you back 1. So 1 to the second power is 1, 1 to the third power is 1, and so on. Right, so that's not allowed. This is a function. It's still a function. It's just not an exponential function. All right, so I want to talk really briefly about the graphs of exponential functions. You won't have to graph any exponential functions in this class, but I just wanted you to have seen it just in case you go on, maybe take an algebra class later, if you take college algebra or pre-calculus, and then in case you see this again, I wanted you to have seen it before. It says, the graph of an exponential function is not a straight line. Typically, the graph of an exponential function is nearly horizontal over a large portion of the x-axis. That's the horizontal axis. And then it turns upward rather abruptly and increases without bound. Now, it could do the opposite. It could be nearly horizontal over a large portion of the x-axis and then turn downward rather abruptly and decrease without bound. All right, so it could be either one of those. I'll show you a picture of what they look like. And it says, because of this curvature, the slope is not constant. Y'all remember slope is rise over run. So the slope is not constant when we're talking about exponential functions. The vertical change will be minimal where the graph is nearly horizontal, whereas the vertical change will be pretty extreme where the graph gets steep. All right, so you can't find the slope the way that we did with linear functions back in chapter, what was that, chapter 12? Yeah, chapter 12. You can't find the slope like how we did back in chapter 12 when we're dealing with exponential functions. All right, here we have a couple of graphs. You can tell this is where it's increasing without bounds. So this is the graph of y equals 2 to the x. So you can see it's horizontal over this entire portion here, or it's almost horizontal. If you zoom in really close, it does have a slight slope to it, but it's nearly horizontal over that entire portion of the graph. And then all of a sudden at this point, looks like about right here, it starts to increase, and the further we get down the graph, it increases faster and faster. That's the main characteristic of an exponential function that sets it apart from other functions, is how fast it increases or how fast it decreases. All right, so this is y equals 2 to the x. The next graph that we're going to look at is y equals 2 to the negative x. All right, so you can see if you have a negative exponent, this is where it's going to go down, it's going to decrease. All right, so you can see if we're starting on the left, you read graphs just like how you read sentences. You always start on the left and you move towards the right. All right, so you can see on the left here, it's decreasing really fast. So I'm looking at this whole portion here of the graph. So it's decreasing really fast there. And then all of a sudden, that stops, and then over this entire portion, it's nearly horizontal. All right, so sort of the opposite of what we just saw. All right, so that's what the graph of exponential functions looks like. Now I need to talk about one special exponential function. This is called the natural exponential function. The natural exponential function is y equals e to the x. Calculations involving e to the x will be performed on a calculator. All right, so let me talk briefly about e. E is a number. It's just like how pi is a number. So everyone knows, or you probably know, that pi is 3.14. Well, e is a number just like how pi is a number. And e is something like 2.72 approximately. It's called an irrational number, and we use it because it describes a lot of natural phenomenon. So that's why it's called the natural exponential function. This exponential function is used to describe population increases, so increases in populations in a city, or it could be like populations of animals in a maybe in a rainforest, or animals in a state park. So it's used to describe a lot of naturally occurring phenomenon. And it says e to the x grows much more quickly when x is a larger number. Right, so if you have a big number in there like e to the 100, that's going to grow really fast. And then when we are dealing with population growth, the larger the population, the faster it grows, which makes sense. Imagine if you have a population, let's say you have a city, and all of a sudden 100 people move into the city. Well, those people are probably going to, have children, so the population is going to grow with every child that they have. And then also, if you have an even larger population, so imagine instead of 100 people, you had 1,000 people. Imagine how many more children are born each year when you have 1,000 people in a city compared to 100 people in a city. Right? So again, when your x value, your independent variable, is larger, then the population grows faster. All right, so we're done for a little bit talking about exponents. We'll come back to them in just a minute. It says, the idea of finding the exponent to which a number must be raised in order to get some particular number is the central concept of a logarithm. Now that sounds a little bit confusing, so I'm going to explain what I mean by that. All right, so suppose I asked you this question. 3 raised to what power gives you 9? All right, so 3 raised to what power gives you 9? So that question in mathematical form, or in an equation form, would be 3 to the x equals 9. So 3 to what power gives us 9? Well, we know that 3 squared gives us 9, or 3 to the second power gives us 9. So to answer that question, you would say 3 raised to what power gives you 9? You would say 2. Now what about this question? 2 raised to what power gives you 8? This might be a little bit harder. 2 raised to what power gives you 8? So how many times do you have to multiply 2 by itself to get 8? Alright, so that's the same as this equation. 2 to the x equals 8, so 2 to what power equals 8? Well, that's 3. So 2 to the third power, 2 times 2 times 2 is 8. But now let's think about this question. 4 raised to what power gives you 9.3? Well, that's not something that we can easily answer. That's not something that we have memorized or that we can easily figure out in our head. And the reason, or the fact that questions like this exist, this is the reason that we use logarithms. All right, so since we have questions like this where we can't figure this out in our head, that's the purpose and the important reason that we use logarithms. Here's the formal definition of a logarithm. It says log base b of u equals v means the same as b raised to the v equals u. In either equation, b is called the base and must be a positive number, but b is not allowed to be 1. Alright, so the first part up here, this is called logarithmic form. Alright, so logarithmic form. The second part down here, this is called exponential form. Alright, so we have logarithmic form circled in red and exponential form circled in purple. And let me just read this to you one more time so you know how to read it in your head. Alright, so I'm starting up here. Log base b of u equals v means the same as b to the v equals u. Alright, so I just want to point out before we move forward, this right here, this is not log base b times u. That is not what that means. This is log base b of u. So this is where you're plugging the number u into that logarithm. So the logarithm is a function on your calculator. So if you want to take a second, pause the video and look at your calculator, see if you can find the log button on your calculator. There should be a button that says log, and you'll also see a button that says ln, which we'll talk about in a little bit. If you can't find the log button on your calculator, you can either email me, you can send me a picture of your calculator and I'll show you where it is, or you can go on Google, search the name of your calculator, and then type in like logarithm. Right, so search the name of your calculator, what it says at the top of your calculator, and then search logarithm with that. And it should pull up a video or at least a picture of where your log button is. Now this definition of a logarithm allows us to rewrite a logarithmic equation as an exponential equation. Now why would we want to do that? The reason why we want to rewrite logarithmic equations in exponential form, remember that's what we called this part here. So we're basically converting it from logarithmic form to exponential form. The reason we would want to do that is because exponential equations are something that we can easily solve. These are much easier to solve in your head than logarithmic equations are. So that's the reason why we'd like to convert them into exponential equations. Now down here at the bottom, I'm going to give you the shorthand version of this definition. I write this at the top of every problem that I have to do that involves logarithms. Now the problems on your homework are not going to use this equation or use this formula. Like I said at the beginning of the video, all the questions on your homework are going to be is just practicing using the calculator. But we will have to use this, I believe, in the next section, maybe the next 2 sections. All right, so this is the shorthand version of that definition. It says log base b of u equals v means the same as b to the v equals u. All right, so this double-sided arrow right here, that indicates that those two are the same, that they mean the same thing. All right, so the double-sided arrow indicates that those two equations mean the same thing. All right, so I'm going to show you how we can use this, this definition in the next problem. So it says, example, find the value of the specified variable. All right, so we got 3 problems. The first one is find v if v is equal to log base 2 of 8. And then part B says find u if log base 5 of u equals -2. And then the last one says find b if log base b of 9 equals 2. So part A says find v if v is equal to log base 2 of 8. So the first thing I'm going to do is rewrite my definition up here. And that's going to help me convert this into exponential form, excuse me. So this definition is going to help me convert this into exponential form. All right, so I'm going to take the left-hand side over here. So I'm going to take this side, and I'm just going to rewrite it under here. And you can see I just flipped it around. I put the v on the left-hand side and the log on the right-hand side because that's the order that it's in my problem. All right, so I'm just writing it underneath. And now what I'm going to do is I'm going to match up each one of the little letters in my definition under here. I'm going to match up each of these letters with their corresponding variable or number. All right, so my first match is v matches with v. All right, so v is just v, which is fine. It seems kind of like, duh, of course v is v, but you'll see as we go on how this works. All right, next we're going to match up b. So b matches with 2, so write that down. And then our last one, u, matches with 8. All right, so write that down. All right, so now we know what each of our letters represents. Now what you're going to do is you're going to take those 3 numbers or variables and you're going to plug them in to the right-hand side of your definition. All right, so we're going to take those and plug them into the right-hand side of our definition. All right, so and for b, we're plugging in 2. For v, we're just plugging in v. And then for u, we're plugging in 8. So we have 2 to the v equals 8. And now you have to ask yourself the question, 2 raised to what power gives you 8? So 2 raised to what power gives you 8? Well, we just answered that. We said that 2 raised to the 3rd power gives you 8. So v must be 3. Now, if you couldn't figure this out on your own, that's okay. All you would have to do is just plug in different numbers on your calculator until you could figure it out. So try plugging in 2 raised to the 1st power, then 2 raised to the 2nd power. So just kind of go through one by one and try until you find the right answer. But most of these, I think you'll be able to figure out. These are going to be easy numbers. You should be able to figure them out in your head with little trouble. Now let's look at our next one. It says find u if log base 5 of u equals -2. All right, so let's rewrite our definition. The other reason that I like to rewrite the definition every time is because the more you write it, the easier it's going to be for you to memorize. Now, I think I have a formula sheet made for this section, so you don't have to have this memorized, but it just makes the work go faster if you do have it memorized. So you can just immediately recall the appropriate definition, and you can get started with the problem. You don't have to keep referring back to your formula sheet. Okay, so let's get started. just like we did last time, the first thing you're going to do is take the left-hand side of your equation, so right here, the left-hand side of your definition, and you're going to rewrite it underneath your problem. Okay? This time the log is on the left because that's the way it is in my problem. So I'm just writing it so where it'll match up easily. All right, so remember what we did next. We went through and we matched up each one of the variables, or each one of the variables in our definition with the number or the variable in our problem. All right, so B matches with 5, so write that down, B is 5. U matches with U, so U is just U. And then V is -2, so write that down, V is -2. All right, and remember what we did next. We took these 3 letters or variables, or excuse me, let me say that again, numbers or variables, and we plugged them in to the right-hand side of our definition right here. So we're plugging them in to the right-hand side of our definition. B to the V equals U. All right, so B is 5, U is U, and V is -2. All right, so we have 5 to the -2 equals U. All right, so to figure out what U is, that's what we're trying to find. It says find U at the beginning of the problem. So to figure out what U is, we just need to plug this into our calculator. Make sure whenever you plug this in, make sure you use a negative in front of the 2 and not a minus sign. If you use the minus sign instead of the negative, it'll give you an error on your calculator. All right, so let's plug this in. I'm showing you me typing it in over here. 5 raised to the -2 is 0.04. So 5 raised to the -2 is 0.04. You can convert this to a fraction if you wanted to. As a fraction, this is 1/25. But I'm fine with you leaving it in decimal form. All right, so U is 0.04. And then our last part for this example, part C, says find B if log base B of 9 equals 2. All right, so find B if log base B of 9 equals 2. All right, so just like we did last time, we rewrite the definition. Then we're going to take our left-hand side of our definition and we're going to write it underneath our problem. All right, so log base B of U equals V. Now we're going to go through and we're going to match up, figure out what our variables are. B is just B. All right, B is B. Get this out of the way. Here we go. U is 9 and V is 2. All right, now we're going to take those and we're going to plug those into the right-hand side of our definition. Plugging it into the right-hand side of our definition right here. B to the V equals U. All right, so B is just B. U is 9 and V is 2. All right, so we have B squared, or B to the second power, equals 9. All right, so now you have to ask yourself, what number squared is 9? All right, what number squared gives you 9? All right, and the only number that you could square and it give you 9 is 3. So B is 3. All right, so I need to talk a little bit more about logarithms. I need to talk about 2 special kinds of logarithms. The most frequently used logarithms are the common logarithm and the natural logarithm. All right, so those are our 2 logarithms that have names. And these are the 2 types of logarithm-related buttons that you have on your calculator. All right, so let's go through and look at each one of these individually. Common logarithms are base 10. So it says log base 10 of x, in which 10 is the base, is called the common logarithm. Base 10 logarithms are used so commonly that the base is understood to be 10 even when no base is written. All right, so here's what that means. It says if you see y equals log of x, you should automatically know that this is the same thing as y equals log base 10 of x. Right, so you can see in our little logarithm here, there's no base indicated. There's no little number here. So if you see a logarithm like that where there's no little number down there, then you should automatically know that's the same thing as log base 10. Now, this on your calculator, this button is going to look like this. So it's just going to be a little button, and it's just going to say L-O-G, log. So that's the common logarithm button on your calculator, the one that says log. This is the formal definition of the common logarithm. It says y equals log of x means the same as 10 to the y equals x. Now, I think this is a good definition. You don't necessarily have to have it memorized because you could just use that last definition of logarithms that we used, but I think it is useful. So again, you could rewrite this sort of similarly to how I did in the last one, where you would write y equals log of x, and then do your little double-sided arrow. So it means the same as 10 to the y. Sorry about this being sloppy, equals x. I don't know why my little 0 got so small there. All right, but that's how you would rewrite it in that same form that we did for the last definition of logarithm. All right, so this is just the special definition or the special version of the definition for common logs. All right, now let's look at the natural log. The number e is often used as the base of a logarithm, and that's why we call it the natural logarithm, because remember before we called it the natural exponential function when it was involving e. All right, so it says y equals log base e of x is called the natural logarithmic function and is abbreviated y equals ln of x. All right, so again, if you see y equals ln of x, you should automatically know that means the same thing as y equals log base e of x. And remember again, e is a number, that's that irrational number, it's like approximately 2.72. Now on your calculator, this button will look like this. It'll say ln. All right, so it's the ln button on your calculator. All right, so take a second, see if you can find those. Here is the natural logarithm definition. It says y equals ln of x means the same as e to the y equals x. And again, you could rewrite this the way that I did before. I like to do a cursive ln just so it doesn't look like a 1. So if you just write it straight up and down for the L, it kind of looks like you have one N instead of ln. Alright, so if you wanted to rewrite it this way, you would have y equals natural log of x, or ln of x, is the same thing as e to the y equals x. The last thing I want to do is go over a couple of problems from your homework. First, I wanted to show you how to do problem number 2. Again, you're just taking your calculator and you're plugging in these expressions to find the value. And it says to round answers to 8 decimal places. Right, so I'm just going to show you how I'm plugging this in the calculator. So for part A, we have 3 and then e raised to the 0.03, closing my parentheses, equals 3.09136360. So that's 8 decimal places. And then again for the next one, you can see me typing it in there. I'll go through that again. 3 and then parentheses. I'm just typing it in exactly the way that it appears on this assignment. So 3 and then parentheses 10 raised to the 0.03, close parentheses. That's 3.21 45571, and then the 1 will round up to a 2. Alright, so pretty simple. I'm going through these quickly because you're just plugging it in the calculator. There's no actual work to be done. Alright, now very similar. It just says use a calculator to find each value. Round your answers to 8 decimal places. So the first one we have is 7 divided by e raised to 0.21. Alright, so I'm going to let you see me plug that in again. 7 and then divided by e raised to, it opens a parentheses for me, 0.21, I close the parentheses, and that's 5.67408972. And then very similar, 7 divided by 10 raised to 0.21. So you can see me plugging that in here. And notice that I don't put a parenthesis around the exponent here. The only reason it has one for the e in the problem on the left is because it went ahead and opened one up for me. So I just made sure to close it whenever I was done with the exponent. Alright, so we have 4.3161501. Alright, and then last homework problem, use a calculator to find each value, round to 8 decimal places. We have natural log of 2.64. So identify or look on your calculator, look for the LN button. Again, if you're having trouble finding that, just search the name of your calculator and then search natural logarithm. It should come up with something and show you. Or you can send me a picture of your calculator and I'll show you where it is. Alright, so that's 9.970778917. And then lastly, we have the common log, so that's log of 2.64. We know that even though there's no base indicated there, that's a base 10. All right, so here's me plugging that in, log, and then it opens up a parenthesis for me. So 2.64, and then I close the parentheses. So that's 0.42160392, and then round up to 7. Alright, so hopefully you won't have much trouble with this homework. This was just a brief overview of exponential functions and logarithmic functions. If you do have any questions, don't forget you can always, you have a lot of options. You can message me on WebAssign. You can hit that Ask Your Instructor button and that'll send me a message. You can post in our coffee shop Q&A on D2L, or you can send me an email at jberry@ccga.edu.